Hey guys, welcome back. In this tutorial, we're going to learn how to find HCF or GCF of two or more numbers. So HCF stands for highest common factor and GCF is just the greatest common factor. So they're both the same thing. Okay, let's start with some simple examples. Let's find the GCF or HCF of 10 and 25. So the easiest way to find HCF of two numbers is just to list the factors. Now, what is a factor? A factor is a number with which you can divide a number and not get a remainder. So for example, the factors of 10 are 1, 2, 5, and 10 itself. Because you can divide 10 by 1, 2, 5, and 10 and not get a remainder. So you can fully divide 10 with these four numbers. So these are the factors of 10. Now let's list the factors of 25. So of course is 1, 5, and then 25. Now what we're going to do is we are going to find the highest common factors. So the highest common factor between these two is just 5. So HCF of these two numbers is just 5. Now let's take another example. Let's find the HCF of 9 and 36. So let's list the factors of 9. So it's 1, 3, because 3 times 3 is 9, and then 9 itself, we stop here. And then 36 is 1, 2, we can divide 36 by 2, 18 times 2 is 36. We can divide 36 by 3, 4. We can also divide 36 by 6, 6 times 6 is 36. And then 8 times 4 is 32, so it's not divisible by 8. 9 times 4 is 36, so 9 is a factor of 36. Then 12 times 3 is 36. 18 times 2 is 36, and then 36 times 1 is 36. So we stop here. So these are all the factors of 36, but we can simply stop at 9 because we have found the highest common factor. And going to 12, 18 doesn't really help because it won't be larger than 9. So 9 is the HCF of 9 and 36. Now let's find the HCF of 9 and 36 using prime factorization. So I'm gonna write 9 and 36 here, and then I'm just gonna start drawing our tree here. So 9 can be broken down into 3 times 3, and this is where we stop because we can't break it down further. So 9 can just be represented as 3 to the power of 2 because 3 times 3 is 9. Now 36 is just 2 times 18. 18 we can further divide by 2, so we get 2 times 9, and 9 we can further divide by 3, so we get 3 times 3. Now let's circle our branches or the end here. So we have 3, 3, 2, 2, and here we just had 3 and 3. So this we can rewrite this as 2 to the power of 2 times 3 to the power of 2. Now here, when we are finding the HCF, we have to find the lowest power of each number in both sets. So here we do not have 2 here, so we can just simply write 2 to the power of 0 because 2 times 0 is 1 and it's not going to change the result. Now we are going to pick the lowest number, lowest power from both the sets here. So here we have 2 to the power of 0 and 2 to the power of 2, so we pick this one, and here we have 3 to the power of 2 and 3 to the power of 2, so we can pick either one. So we're just gonna pick these two. So this just becomes 3 times 3 is 9, 2 times 0 is 1, so this just becomes 9. So HCF of 9 and 36 is 9. Now let's take another example. Let's find the HCF of 336, 54, and 60. Now if you were to just list the multiples, it's just gonna get much harder because you have 336. It's gonna take a while. So for smaller numbers, you can just list all the factors and get your HCF from there. But if you have like larger numbers, it's much easier to use prime factorization to find the HCF. Okay, so let's find the prime factors of 336. We can divide 336 by 2 since it's ending in 6. So 2 times 168 is 336. 168, we can further divide this by 2 because the last number here is an even number. So this just becomes 2 times 84. And then 84 we can further divide by 2, so it becomes 2 times 42. 42 we can just write this as 7 times 6. 6 we can further break it down, we can say this is 2 times 3. Now let's circle all of our branches here, or all the ends here, so it's easier to identify. So we have 2, 3, 7, 2, 2, and then 2. So this can be rewritten as 2 to the power of 4, because we have 4 2's here, 1, 2, 3, 4, times 3 to the power of 1, and then times 7 to the power of 1. Now let's find the prime factors of 54. So we can divide it by 2 because it's ending in an even number. So 54 just becomes 2 times 27, and then 27 we can further say this is 3 times 9, and then 9 is just 3 times 3. Now let's circle all of our prime factors here. So this just becomes 2 to the power of 1 times 3 to the power of 3. And then since we have a 7 here, we do not have a 7 here, so we can simply say 7 to the power of 0. Now let's find the prime factors of 60. So again, we can divide this by 2. 2 times 30 is 60. Then 2 times 15 is 30. And then 3 times 5 is 15. So the prime factors are 3, 5, and then 2 here. So we can rewrite this as 2 to the power of, we have 2 2's here, so 2 to the power of 2 times 3 to the power of 1 times 5 to the power of 1, and then since we have 7 here, we are also going to write 7 here, so 7 to the power of 0. And now since we have 5 here, we're simply gonna multiply this by 5 to the power of 0, just so we have this prime factor in each of our set. So this is also gonna be times 5 to the power of 0, because 5, any number to the power of 0 is 1, and it doesn't change the result. So now what we are gonna do is we are gonna pick, for HCF, we are gonna pick the lowest number from each one of them. So 2, what is the lowest power of 2 here? So 2, we have 2 here, 1 and 4, so we're gonna pick this one. So we have 2 to the power of 1 times, now let's consider 3, we have 1, 3 to the power of 3, and then 1, so we can pick 3 to the power of 1 times, now what's the next number? We have 5 here, and the lowest power of 5 is 0, so we're going to multiply it by 5 to the power of 0 times, and then we have 7 here, 7 also, 7 to the power of 0 is the lowest number. Now these two are just ones, so HCF just becomes 2 to the power of 1 is what? 2, times 3 to the power of 1 is 3, times 5 to the power of 0 is just 1, and then 7 to the power of 0 is just 1 again. So this just becomes 2 times 3 times 1, which is 6. So HCF of 336, 54, and 60 is 6. If you found this helpful, please leave a like and subscribe to my channel, and let me know if you guys have any questions. Thank you for watching.